This protocol demonstrates the use of a syringe-driven direct injection vaporizer as part of a digital low-flow anesthesia system. The direct injection vaporizer accurately delivers anesthesia at very low flow rates compared to a traditional vaporizer, making it a promising alternative for controlled anesthetic delivery to rodents.
There are many precision vaporizers available for veterinary use that operate between 0.5 and 10 liters per minute. These flow rates are not ideal for rodents as the range is well above their small respiratory minute volume. The main advantage of this vaporizer is that an animal can be maintained with a nose cone using a flow rate as low as 1.5 times the animal's minute volume. Thus, a 30-gram mouse could be maintained at a flow rate as low as 52 milliliters per minute.
First, select a carrier gas source. To utilize the internal air pump, unscrew the rear inlet port, allowing the internal pump to take in room air. Then, connect a charcoal canister to the exhaust port. Next, connect the delivery tubing to the anesthesia system. Use the color-coded clips to designate the branches for the nose cone and the induction chamber. Open the clamps to direct airflow to the chamber. For physiological monitoring, connect the pulse oximeter pause sensor to the back of the low-flow anesthesia system. Turn on the low-flow anesthesia system to configure the settings. Navigate to the Anesthesia Setup menu and choose isoflurane. Next, set the syringe size by pressing Setup to highlight Syringe Size. Use the directional buttons to select a 2 milliliter syringe.
It is important to use the appropriately sized syringe for your animal and length of procedure. This system is compatible with 2, 5, and 10 milliliter syringes to accommodate a variety of applications.
After selecting the syringe size, set the empty position of the syringe. Now, secure the empty, fully depressed glass syringe in the syringe retention block. Place the syringe so that the holding clamp is seated on the metal collar of the syringe. Adjust the pusher block so that it makes light contact with the top of the syringe plunger. Save the empty position. Remove the syringe and then fill with isoflurane using the bottle top adapter. After filling, place the syringe back into the retention block and attach the delivery tube. Next, prime the anesthetic delivery tubing by pressing the directional buttons. The system will depress the syringe until the anesthetic travels into the vaporizer block. It is important not to overprime the syringe. Once all settings are made, enable anesthesia delivery. Now select the air supply to room air and the minute volume to 250 milliliters per minute. For physiological monitoring, set the minimum detected heart rate to mouse Begin the airflow to induce anesthesia in the mouse. Place the mouse in the induction chamber, close the lid tightly, and adjust the anesthetic agent concentration dial to deliver 3%. Monitor the mouse until it reaches the desired plane of anesthesia determined by loss of the righting reflex. Once the animal is sufficiently anesthetized, turn the anesthetic agent concentration dial to deliver 0%. Then, open the clamps to direct the airflow to the nose cone and close the clamps leading to the induction chamber. Remove the mouse from the chamber and immediately place on the nose cone. Next, center the animal on an infrared warming pad set to maintain body temperature at 37 degrees Celsius via a rectal probe on a feedback loop. With the mouse positioned on the nose cone, adjust the concentration of isoflurane to 1.5%. Now, reduce the minute volume to support anesthetic maintenance. Confirm the depth of anesthesia as determined by a lack of withdrawal reflex during an interdigital pinch. Apply ophthalmic ointment to the eyes to prevent dryness during anesthesia. Begin physiological monitoring by placing the sensor over the pad of the hind paw. Position the sensor so that the red light illuminates the paw. Display the octave wave in order to visualize the sensor signal. Turn the anesthetic concentration dial to minimum to deliver 0%, and remove the animal from the nose cone. Monitor the mouse closely during anesthesia recovery. Once the mouse is fully ambulatory, return it to the cage. This figure shows the amount of isoflurane used in milliliters for 3 different 6 to 7-week-old C57 Black 6 female mice over 1 hour of anesthesia maintenance using the digital low-flow anesthesia system. Due to the low flow rates, the low-flow syringe-driven digital vaporizer consumed less than 1 milliliter of isoflurane over the course of 1 hour. The heart rate of the 3 mice, measured in beats per minute using pulse oximetry at 5 to 60 minutes after induction, is shown here. The animals' heart rates remained relatively stable and consistent through the maintenance period. This figure shows oxygen saturation levels of the 3 mice over the same time period. Finally, the respiration rate of the mice in breaths per minute between 5 and 60 minutes after induction with the digital low-flow anesthesia system is shown here.
The internal air pump offers users the option to anesthetize animals without requiring a compressed gas source. For procedures requiring compressed gas or supplemental oxygen, the user has the option to connect a gas source to the low-flow vaporizer, rather than using air. Low-flow syringe-driven vaporizers are capable of flow rates as low as 10 milliliters per minute while delivering accurate anesthetic concentrations. Thus, this technique will be beneficial to groups performing rodent anesthesia due to improved safety, efficacy, and precision over traditional systems.